Still dealing with exponential functions and logarithms. There are two basic strategies for solving exponential functions and logarithms. The first one's one-to-one, and we dealt with one-to-one, because if the bases are the same, we can set the exponents equal to each other and solve. Now the second is based on the inverse property of this here, to where we can say, so one-to-one, a to the x is equal to a of the y, if and only if x equals y. Same thing for logs. Now the inverse property is saying a log base a of x is equal to x, and log base a, this kind of here. Now, and this is kind of delving into how we would do this, kind of the different properties, and it'll make more sense once we actually look at it. So the first one here, we could use the one-to-one property, because 32 is 2 to the 5th. The bases are the same. So x is equal to 5. That's our one-to-one. Here, ln of x minus ln of 3 is equal to 0. Well, I can get it to be ln of x equals ln of x, yes? Because I can add 1 ln of 3 to both sides, and we get them equal to each other, yes? Well, this here is one-to-one. So we can say x is equal to 3. And again, with this here, 9 is 3 squared, 1/3 x. Well, I can rewrite it as 3 to the negative x. We can rewrite these. Are we good with these here so far? Which means x is equal to negative 2. This is one-to-one. Now we're looking at this next one. E to the x equals 7. Well, there's no way to make this one-to-one, is there? No. Expand this page out. I'm going to do something a little bit different. I'm going to apply the natural log to both sides. It could be ln of e to the x is equal to ln of, what can we do with the exponent? We can move it. What is ln of e? Plug it in. Four, 5, 9, and that's it. I was going to say ln of 7 is going to say the inverse, but pretty much if we want to find the exact value, that's what we would do. Questions on this here? Okay. Now, erase this here. You over, I want you here. Come here. White, white. Okay. There we go. That'll work. Let's see if I can do this. Wait, there we go. Okay. Now that worked for that one, that's fine. ln of x equals negative 3. Well, we know that when the bases are the base and the number inside the log are the same, they cancel out, yes? Now it also works out that if I take e to the ln of x, well, these would cancel, leaving me with just x, yes? Because I can put both sides to that power, and if the base and the number that's 2, or it's been put to, are the same, it'll cancel out. But I do it to one side, I have to do it to the, so this tells me x is equal to e to the negative 3. That's it. And at this point, we could plug it into the calculator and it'd give us a numerical answer. That's all we'd have to do for this here. That should be negative 3. Questions on this here so far? So that's not bad, because ln is e. What would we put both sides to here? What is the base? It is 10. It's understood to be 10, so we put both sides to the 10th power. Questions on this here? Well, 10 and the log would cancel, leaving me x is equal to 10 to the which would be 1/10. We just move it down into the denominator, and that's it. And last but not least, so what are we going to use this time? 3, because the base is. So we put both sides to the third, because those would cancel, leaving me with just x is equal to 3 to the 4th. 3 squared is 81. So 81, or not 81, 3 squared is 9. 9 and 9 would give us 81. Because it's 3 times itself 4 times. So 3 times 3 is 9. We need it 2 more times to get 4. So it's 81. And that's it. That's all we have to do for these here. Questions on this here? Any questions on any of this here? 2 to the x equals 2 to the 5th. So this is the first one we had, and we said x equals 5, yes? What happens if I apply log base 2 to both sides? Well, the x and 5 would come out front, yes? Log base 2 of 2 is equal to 5 times log base 2 of 2. Well, that reduces. That's one-to-one property. We skip that step and just say the exponents are equal, but it's the same thing. It's the same property. We just do it in a little different fashion. Questions on this here? We good with this here? So strategies, example 1, are summarized as rewriting the original in a form that's one-to-one, rewrite an exponential using, and kind of applying these properties. So we're going to look at this first. So what can we do to solve this here? Yes, because the bases are the same, we can set the exponents equal to each other. It's a quadratic. So how many answers should I have? 2. They might not be unique, but I need 2. So I'd add x squared to both sides, which will tell me that 0 is equal to x squared minus 3x minus 4, not plus 4. Now at this point we could graph it, because if it has whole number answers, graphing it will tell us it. It would be 1 and 4. Now if we factor it, well since 4 is negative, the signs are opposite. The factors of x squared would be x and x. Because x times negative 4 would be negative 4x. 1 times x would be plus x, which gives us our that we wanted. Now the zero product property says that because I have 2 things multiplied together to equal 0, one of them has to be 0. We can set them equal to 0. And those are our 2 values. Questions on this here? And that's it. That's all we'd have to do for this here. Now, because it's in the exponents, we don't have to worry about restrictions. If it's positive or negative, that's fine. Because if we plugged it in, so negative 1, well, negative 1 squared is 1, and because the negative outside would give us negative 1. Okay. I'll fill it in. So negative 1 squared would give us 1, but because of the negative, it's going to be negative 1. Now, negative 3 times negative 1 is positive. Minus 4 is. We're good. Okay. 4. Well, that'd be e to the negative 16. Well, negative 3 times 4 is negative 12. Minus 4 is, we get the same value. So it works either way. Because where do we have to be careful? We have to be careful with logs and natural logs because we cannot have a negative inside of a logarithm. It just doesn't work. Because what we're saying, if I have log of negative a equals y, we'll call this b. Really what I'm saying is b to the y is equal to negative a. Because if we remember most of our graphs of these logarithmic functions, they do not go below the x-axis. I cannot have a negative value for it. Because b to a positive y value is going to give me a number greater than 0. Because any number I take, any power, is going to be greater than 0. As long as b is greater than 0. Because it technically wouldn't quite be an exponential function if b was less than 0. B is negative. Let's say b is negative 2. Well, negative 2 to the first is negative 2, yes? What's negative 2 squared? It's increasing fast, isn't it? What's cubed? Well, that's not increasing, is it? Because how do we define an exponential function? It's either increasing or decreasing. It's either decreasing towards 0 or it's increasing towards infinity, yes? This is what, if I remember correctly, is called an oscillating function. Because we're here, and then we're up here, and then we're here. Because it's going to be the sign is going to cause this to jump above and below the axis. So this here isn't technically an exponential function because it's going to jump like this constantly. So we consider that to be an oscillating function. Now, because if y is greater as positive as we just, except for it being negative, it would go up because we had 2, 4, 8, 16, 24, would go that direction. Now, if b to the negative y, well, that's the same as 1 over b to the y. But that's still going to be greater than 0 because the only way for that fraction to be 0 is if the numerator was 0. Is the numerator changing? No, it's still going to be 1. So there's no way for this to actually go below the x-axis. So nothing inside the log can be negative. Now that probably probes the question, is it possible for something we plug it into a logarithmic equation and it come out to be negative? Yes. If we have a vertical shift. If we are subtracting number outside the log. So outside the log would cause the overall thing to be negative. But the number inside the log, where a is, still has to be positive. So it has to be positive. Okay, let's look at the next one. So we want to solve this here. It's going to be easier if we get the variable and the exponent, or the number with an exponent and the variable by itself first. That's going to be easiest. So how can I do that? I can divide both sides by we have this here. what can we do next? So we can apply logs, we can apply natural logs, but we need to do something to get the variable out of the exponent. What do you think is going to be the easiest thing to do? I mean, we can apply log to both sides, yes? Then what would we need to do? With the exponent out front, so I have x log of 2 equals log of, okay? Questions on this here? Then what can we do? Divide both sides by? Those would cancel, leaving me with x is equal to and we can type it in. Then we can type that into a calculator and get one more. And that's it. Questions on this here? Now, some of the times I'll use ln instead of log. I can do ln of both sides. That works out well. Another way I could have done this is done log base 2. On both sides. What there is which is the same thing. Because again, remember I changed the base? Because log base 2 of 14 is the same as log of 14 over log of 2. It's just the change of base formula. So this is another way we can do it. Questions on this here? We good with this here so far? Okay. Yeah, so we started off with ln of x equals 2. And we can put both of these to the e power because e and ln would cancel, leaving us x is equal to e to the second. And it turns out that's approximately 0. Yep. And that's it. So we applied both sides to e because, again, when we put the base and whatever it's powered to are the same because this is e, they simplify out. Questions on this here? Now this here we could really, so the next one we could put both things to the third power. Or the fact that they are 1-to-1. The bases are the same, so we can do 1-to-1. So we would eight. So 8. Get ahead of myself. So x is equal to 2. Questions on this here? We good with these here? Solve the following logarithmic function. So looking at this here, this isn't quite 1-to-1 because I have 2-to-1, don't I? But they all have the same base. But this would be log base 6 of You're good. It's going to be over 5 because whenever we have two logs being subtracted with the same base, it's the same as division of what's inside the logs. So we can rewrite it as this here. Then we would use 6 and 6 are the 1-to-1 property, plus 14 equals, I would multiply both sides by 5. Because really this would be 5 over 5, which would cancel out. That's why we would do that. Because then we would just have 3x equals, then what? Subtract 3x from both sides. These would and that's it. Questions on this here? So in some of these here, we have to use the properties of logs to simplify down. But that's it. And again, we can come back in using PERT, our percentage, principal times e to the rate times time equals the overall amount. So if they told us that the overall interest or the overall amount was $1,000, how long would it take it to get there? We can go on and solve and say the time would be 10.27 years. $10.27, so 10 years and 3 months. 0.27, let's just say 0.3 times 12 would be 3.6. 36, 3 times 12 is 36. Move the decimal over 1. Or, yeah, 3 months. You're right, 3 months to get there. So interest does take a while to add up and accumulate, but that's it.